Hello ladies and gentlemen, this is Mr. Santoro. Welcome to the second review lesson on factoring. So today we're going to look at factoring some trinomials and the difference of two perfect squares. So to get started, let's take a look at what I have on the screen here. Multiply out x plus 3 times x plus 5. So remember distributive property. Multiply the x times the x, you get x squared. X times 5 is 5x. 3 times the x is 3x, and 3 times 5 is 15. So if you take a look at the two binomials that we started with, the signs in the parentheses are all plus, so are they in our multiplied version. The 3 times 5 is 15, that's the last term. So that's how you derive the last term. It's the last term in each of the sets of parentheses. Multiply gives you the last term. Now if you notice, the two middle terms are the like terms that you'll combine. So 5 and 3 is 8. The final answer is x squared plus 8x plus 15. So now let's take a look at this. If you recall, factoring is the reverse of this multiplication, the distribution. So if we look at the do now, you find out that when you multiply them out and combine the like terms, you get x squared plus 8x plus 15. So therefore the factors of that are x plus 3 and x plus 5. So let's take a look at this. Let's factor each of these trinomials here. The first thing you want to look at is two numbers that multiply to positive 15. And since the middle term is positive as well, we're looking for two positive numbers that multiply to 15. 15 does not have a whole lot of factors. It's either 3 times 5 or 15 times 1. So then you look for the set of factors that adds up to the middle term. 15 times 1 is 15 plus 1 is 16. 15 times 1 is 15. So the factors of this first expression are x plus 15 and x plus 1. Now let's take a look at the second expression I have here. X squared minus 11x plus 10. The plus sign, the plus 10, tells you the signs in the two parentheses are both positive, are the same, excuse me. And to find out if they're both positive or both negative, you move to the middle term. Now in this case, the middle term is negative. So we're looking for two negative numbers that multiply to positive 10. Negative 2 times negative 5, negative 1 times negative 10. Only one set of those numbers will add up to negative 11. And it's the negative 1 and the negative 10. So the factors of x squared minus 11x plus 10 are x minus 10, x minus 1. Let's take a look at factoring the difference of two perfect squares. Let's start out by taking two binomials and multiplying them. So when you multiply x plus 2 and x minus 2, that's what you get. But notice what happens to the two middle terms. When you combine those two middle terms, they disappear. They drop out because they cancel each other out. If you notice what's in the parentheses, the factors are the same except the signs are different. One's a plus and one's a minus. So that's what happens when you factor the difference of two perfect squares. So let's look at the steps on doing that. So if we start out with x squared minus 9, x squared and 9 are both perfect squares. So you start out factoring with your two sets of parentheses. Then you take the square root of the first term. In this case, the first term is x squared. The square root of that is x, and that goes in the first position in each set of parentheses. The signs will be opposite. And it doesn't matter in this case which is first, whether it's x plus, then x minus, or x minus, then x plus. Doesn't matter. Then 9 is a perfect square. The square root of 9 is 3, and that fills out our binomials. So now let's try factoring two of them. X squared minus 49. So you might want to pause the video now and factor the two of these, then come back and rejoin as we go through the explanation. X squared minus 49. X squared is a perfect square, so is 49. So we know that our parentheses will be x plus and x minus. Square root of 49 is 7. So x squared minus 49 factors to x plus 7 and x minus 7. You could factor at x minus 7 and x plus 7. It doesn't matter whichever you like to put first, the minus or the plus. Now take a look at this last one. It's 16 minus x squared. 16 is a perfect square, so is x squared. So in the parentheses, the square root of 16 will go first. So we have x minus 4, 4 minus x, and 4 plus x. You've got to make sure that you maintain the position. Square root of the first term goes in the first term of the parentheses. The square root of the second term goes in the second spot in each set of parentheses. That's important to make sure that you maintain that, because 16 minus x squared is very different than x squared minus 16. So that's all for the screencast. I tried to keep it short. This is still review of factoring. We'll be doing factoring review for another day or two. So I will see everybody in class.